Hey everyone, welcome back. Today we are solving an interesting problem called number of provinces. So imagine a country with multiple cities. Some are connected by roads while others are only reachable through indirect connections. Our task is to determine how many groups or provinces exist. Okay, so let's read the problem statement. So there are n cities, some of them are connected while some are not. If city A is connected directly with city B and city B is connected directly with city C, then city A is connected indirectly with city C. A province is a group of directly or indirectly connected cities and no other cities outside of the group. So basically group of cities which are connected either directly or indirectly called one province. You are given an n cross n matrix. Our matrix name is connected, where is connected I, j is equal to 1 if ith city and jth city are directly connected. And if I and j are not connected, then it will be 0. Our objective is to find the total number of provinces. Okay, so let's take few examples. So here we can see that city 1 and city 2 are connected. So this is one province and city 3 is not connected. So this alone is one province. So our output should be 2. So here in this example, none of the cities are connected. So we have 1, 2, 3, 3 cities. So total 3 provinces. Okay. Now let's understand this input matrix. So imagine we have 4 cities, 0, 1, 2, and 3. So where cities 0, 1, and 3 are connected with each other and city 2 is not connected to any other city. So in this case, this would be the input matrix. So city 0 is connected to itself. So 1, it's connected to city 1. So this is 1. It's not connected to city 2. So 0. And it's connected to city 3 as well. So 1. Similarly for city 1, it's connected to city 0. 1. It's not connected to city 2. And it's connected to city 3. City 2 is not connected to any other city, so 0, 0, 0. And city 3 is connected to 0, 1, and itself 3, so 1, 1, 0, 1. Let's clear the screen. So let's solve this problem. So this is a common graph problem that tests our understanding on connectivity and depth first search. So this is the graph, and we start from the node 0, and we'll do DFS. So as the name suggests, first we'll go in depth. Okay, so from node 0, we'll go to 1. From 1, we go to 4. From 4, we go to 6, 6 to 7. So you see, we are going in depth. Okay, now from 7, we cannot go anywhere else. So we'll backtrack to 6, 6 to 4, 4 to 1. Now from 1, we can visit to 3. So we'll go there. Now from 3, we can go to 0, but 0 is already visited. So we'll not go there. We'll backtrack to 1 and from 1 to 0. Now from 0, we can go to 2 and from 2, we can go to 5 and then again backtrack to 0. Now let's look at the approach to solve this problem. Since we have a connectivity matrix, we can treat this as a graph problem. Each city is a node and connection represents the edge between two nodes. Okay. Now, to find the number of provinces, we can use DFS. So start from the unvisited city, explore all the cities connected to it directly or indirectly, mark them as visited, move to the next unvisited city, and repeat. The number of DFS calls gives the number of provinces. And why is that? So let's take this as an example. So let's do the DFS here. Imagine we'll start from the city 1. So from city 1, we'll visit city 0, and from city 0, we'll visit city 3. And now we cannot go anywhere else. So DFS is completed. But city 2 is not visited. Okay, so we'll start another DFS from city 2. But we cannot go anywhere else. So we'll mark this city as visited and we'll be done with the DFS. So in total, we are doing 2 DFS to visit all the cities. So that is why number of DFS calls gives us the number of provinces. Okay, so let's clear the screen. Now we can write the code for this problem. So input is n cross n matrix. So first we'll get the rows in the matrix. So length of is connected and the columns length of is connected 0. Now let's have the visited array. This is to keep track of which cities are visited. So initially none of the cities are visited, so false and equal to number of rows. Next, number of provinces, so initialize to 0. Now let's iterate through all the cities. So for start in range rows, now we'll check if this particular city is not visited. So if not visited, okay. And if that's the case, that means we have found a province. So we'll increment the count by 1 and we will start a new DFS from here, from the city. So we'll pass the city, connectivity matrix, visited array, and columns. And at the end, we will return number of provinces. Okay. Now let's implement this DFS method. So self, and it's taking all these as parameters. So first thing first, we'll mark this particular city as visited. So visited true. Now we will check all the cities we can visit from this particular city. So for J in range and columns, so we'll check if start is not equal to J. That means we are checking if the row value and the column value are not the same. So for example, this 0, 0, 1, 1, okay? And is connected start in J equal to 1. That means the city start and the city J are directly connected. Okay, then only we can travel from city start to city J. And city J is already not visited, so not visited. Okay, if all of these conditions are true, then we'll make a recursive call DFS, and this time the start would be J and we'll pass the rest of the values. Okay, so again we'll start the DFS from the city start, and inside this DFS function we'll mark the current city as visited. Then we'll find all the cities which we can visit from the current city and check if those cities are already not visited. We'll make a recursive DFS call from that city. So once this iteration is completed, we'll have number of provinces, and here we'll return those provinces. Okay, so let's clear the screen and run the code. Okay, so both the test cases are passed. Now let's submit this. So our solution is accepted. All 114 test cases passed. Runtime is 7 millisecond and it's beating around 57% of submissions. Okay. And with that, we have successfully solved the problem using depth first search. This is a fundamental graph problem that helps in understanding connectivity in networks. If you found this explanation helpful, please like the video, subscribe, and let me know in comments if you have any other alternative solutions or questions. See you in the next one. Bye-bye.